Hello students, today we are doing a question from surface tension. Right, this question actually it's a basic type of question. You should know it's a theory question actually. In this question they are asking us to find this common meniscus. The question will appear very soon. Try the question first, and if you can do it, that's great. And let's go through the explanation right now. All right. So let's get into the question now. So they are asking us to find this common meniscus. Actually, I don't know whether you can see the common meniscus. The radius of this, the larger bubble is 3 centimeters, and this one it's actually 2 centimeters. So then this is the sphere or the bubble for the imaginary bubble we have here. This radius actually they are asking us to find. Is R value, let's say R dash, common meniscus value, right? So finding this, actually you should know a couple of things. Let's look at it now, right? So let's assume the pressure inside of this as P1 and pressure inside of this smaller bubble is P2, right? And pressure outside as P0, right? So I'm doing actually with this with the very basic theory. So if you know the short method, that's fine, that's great, right? So I need to find the pressure difference across here P2 and now this P2 minus P1. That's what creates. I'll write it here. Which one is greater, P1 or P2? So you can see it's bent actually in this direction. So that means P2 is greater. So I'm going to write P2 minus P1. P2 minus P1 because P2 is greater, right? So then I assume the normal equation. You should know the normal equation. Delta P equals 2T over R. You should know this, right? Then delta P 2T over R, or it can be 40 if it's a soap bubble. Let's say it's a soap bubble, then it's 40 over R. So the value here it should be, that's what we need to find actually, R dash, right? But we do not know P1 minus P2 minus P1, we don't know, but from the other two actually we can get an idea of these two. So let's write the other values, right? P0 minus P1 minus P0, of course we know that is 40 over R value we know it's 3 centimeters, so 3 into 10 to the power minus 2, right? First equation. And the second equation, of course you can write it from this. It's P2 minus P0 equals 40 over 2 into 10 to the power minus 2. That is the second equation, right? Then we need to find what is P2 minus P1, right? So what you have to do is, you can see what's P. We have to subtract second one from the first equation, P2 minus P1. I hope you can see it. So then we are getting what is 40 over R, right? Let's move it. All right. Let's subtract second one from the first one, right? Second one from the first one. So if you subtract second one from the first one, I'm getting P2 minus P1 from these two values. So 40 over 2 into 10 to the power minus 2 minus 40 over 3 into 10 to the power minus 2, right? So then that must be equal to 40 over R. 40 over R dash, this value, right, from the other equation, R dash. So that is 40 over 3 into 10 to the power minus 2, here 2 minus 40 over 3 into 10 to the power minus 2. I hope you can see these values cancel off. 40 cancel off. So let's write them now. 1 over R dash equals 1 over 2 into 10 to the power minus 2 minus 1 over 3 into 10 to the power minus 2. So 1 over r dash, let's take the common denominator 10 to the power minus 2, of course you can take up. So it's 100 over 2 plus 100 over 3. I'm going to take the common denominator here. So it's 6 common denominator. Subtract it. So 300 minus, here you get 200. So 1 over r dash equals, so let's take the reciprocal of this. Then r dash equals 600 divided by 100. 6 divided by 100. So 6 into 10 to the power minus 2 centimeters. Meters. Right. So it's basically 6 centimeters. That's the common meniscus. And if you could get the answer, that's great. And if you couldn't, practice this. Actually, I'm doing this from the very basic theory. That's a shortcut methods, of course. It's always better to practice with them for sure. Go through with the method again, and I hope you learned something new.